So first of all, I'm going to introduce this retention. Do you know what does this retention mean? So retention means basically the spatial arrangement of the bonds before reaction and after reaction. If it will be same, then retention of configuration is there. Retention of configuration is there. So first of all, I'm going to write a point. Retention of configuration is the preservation of spatial arrangement of bonds to an asymmetric center during a chemical reaction. So after you will get it now. If we are going to, I will show you I will show you a reaction. Wait a minute.
So your screen is not visible.
My screen is not visible.
No,
I mean,
sir,
can
not
you?
yet.
You cannot see it. I was writing on this. Can you see the screen
Okay, yes.
now?
Now I can see. Yes.
Okay. So today, Aman, we just started a topic that is retention. And you know what is retention of configuration? The spatial arrangement of bonds will be preserved. As for example, I can take this is our CH3. This bond is H. This bond is CH2. Wait a minute. Is CH2. And this bond is yours. Again, we have here CH2 and then CH3. Now see, we are going to react this reactant with HCl and heat it. What happens here is very easy. The bond will be broken here, and here the bond will be broken, and Cl will go and attach to this CH2 group. So you can see the product will be like this. Product will be like this. So Cl is joined at that place where OH is removed from. So basically we can say Cl just replaced OH. That's why it is retention of configuration. The configuration does not change. There are reactions where the configuration will be totally opposite after reaction, or you can say the spatial arrangement of the bonds will be totally opposite from the reactant. And if you are going to compare it from the product, but here you can see OH is in the plane and here Cl is also in the plane. That's why this is called retention of configuration. Please write it. Did I take any test in the last week?
No, sir.
Let me know when you are done with this. Aman, Madhya, are you done with this?
Sir, just drawing the figures.
Okay. Okay. Are you done with this now, Madhya?
Yes, sir.
What about you? Are you done with this? Nadia, can you see the screen? Aman.
Yes, sir, I'm done.
Okay. Now, version that means totally opposite. Then let me switch off the internet connection unstable. So this is then am I audible to both of you?
See, now you are so
Yes.
good. Before it was not good.
Okay, okay. Now I am audible, right? So see, what I was saying, there are some terms we need to understand. What is this inversion, retention, and racemization? So I'm going to take an example, and then we can easily understand these terms. This is C2H5. This bond shows basically on the plane. Out of the plane, and this is below the plane. This is basically hydrogen. So see, there are two possibility of reaction. If you are going to react this with Y, this Y will be replaced. This Y will replace X and acquire the same spatial arrangement or acquire the same place of X. Like this will be C2H5 and this will be Y and this will be hydrogen. It does not disturb the bonding arrangement. And there is a possibility of reacting Y, like this is our C2H5. Now Y can be here, and this is hydrogen, and this is CH3. So can you see the left side of the reaction? X was on the left hand side, but after reaction, Y replaced X and it is on the right hand side. Are you getting my point? This is our A and this is our B. So this B is called inversion when it arranged itself after reaction opposite to the reactant. This B is inversion and A is retention. A is retention. So if I'm going to write, if A is the only product, if A is the only compound obtained, or if A is the only product, the process is called retention. The process is called retention. It retained its configuration, spatial arrangement of bonds. If B is the only product, if B is the only compound obtained, if B is the only compound obtained, the process is called, the process is called inversion, opposite, inverse. And if you are going to mix this A and B, A plus B in 50 is to 50 ratio, 50 is to 50 ratio, the mixture is called racemization, racemic mixture. The mixture is called racemic mixture, and the process is called racemization. Please write it, then I will write it. What does this A plus B? A has opposite configuration of B. So if A will be dextrorotatory, B will be levorotatory. So you know that one will move clockwise and another will be anti-clockwise. And if both are in same ratio, they will cancel each other's effect and the racemic mixture will be optically inactive. Let me know when you are done. Everyone done with this? Aman, Madiha, are you done with this?
Yes, sir.
Yeah. Aman,
Yes, sir. Done.
very good. Now see, what I was saying is that this A plus B, when mixed in 50 is to 50 ratio, the mixture is called racemic mixture, and the process is called racemises. Racemises. As you know that one is opposite of other, so one will have dextrorotative, and other will have levorotative, and when they will be passed through analyzer, one will rotate to clockwise, another will rotate to anti-clockwise, and they are in same molar ratio, so the rotation will be opposite and equal, so the net rotation will be zero. That's why racemic mixture is optically inactive. Is that clear? Optically inactive. Please write this point and let me know. Racemic mixtures are optically inactive. Are you done with this? Please do respond.
Yes, sir.
Okay. Now see, in the beginning of SN2, I wrote a point that SN2 is SN2 uh, mechanism is from back attack. So this point is very important. SN2 reactions of optically active halides are accompanied by inversion of configuration. Inversion of configuration, because it is from backside. The attack is from backside. You can see this bond is on the plane, and this is hydrogen, and this is like this solid waste dash waste C6H13 I'm going to take, and then this is Br. So if you are going to react this OH minus from front side, it won't be possible, as I told you, because this will be also negative and there will be repulsion. So OH have to move to back side, and it can attack from here easily. So the bond formed will be like this, and you can see the configuration changes. Left appearing right, right appearing left. C6H13 and Br minus will be. So basically you have to keep it in mind that SN2 accompanied by inversion of configuration. Please write. Let me know when both of you are done with this. Both of you done with this? Madiha and Ayman, why are you responding so late?
Sir, I'm not done yet.
Okay.
Done, sir.
Very good. Ayman, are you done with this?
Yes, sir. Now I am.
So SN2 mechanism is accompanied by inversion of configuration. The next point, which is very important, is for SN1. SN1 reactions are accompanied by racemization. Accompanied by racemization. Racemization, that means basically inversion and retention both will be there. I will tell you how it is possible. First, I'm going to write a reaction. You can see this is Br on the plane, CH3 on the plane. Out of the plane, inside the plane. There is H and there is CH2, CH2. Now, if there will be reaction, you know that in SN1, first there will be the formation of carbocation. First, there will be formation of carbocation. This is like this. And then CH2, CH2. Br minus will be eliminated. Now you can see this carbon, which have positive charge, will have vacant p orbital like this. And I'm going to draw bond like this. three bond, carbocation makes three bond, CH3, and here it is CH2, CH3, and here it is hydrogen. Basically, in SN1, both possibility are there. OH can attack from front side as well as from back side. OH can attack from front side as well as from back side it can attack. So OH if attack from front side, this is front side. So it will attack like this and formation will be like this. The place of Br will be replaced by OH if it will attack from front side. This is CH3, this is hydrogen, and this is CH2, CH3. Now, if OH will attack from back side, what happens? Br is on the right hand side. Now OH will be on the OH will be on the left hand side. OH will be on the left hand side. OH. Then this is CH3. This is hydrogen, and this is CH2, CH2. So basically, that's why you can see if one of will be D, then another will be L. And if they are mixed in same proportion, the mixture is called racemic mixture and the process is racemization. And racemization, racemic mixture are optically inactive. Please write this. Am I audible to both of you?
Yes, sir.
Are you done with this, Aman and Madhya?
So 1 minute.
Okay, okay, take your time. Madiha and Anmu, are you done with this?
Done, sir.
Yes, sir.
Okay, so this was about SN1 and SN2. I think uh, that's clear now. Do you have any doubt, any one of you? Now we are going to
No,
start
sir.
next chemical properties, that is elimination reaction. After nucleophilic substitution reaction, SN1, SN2, we have elimination reaction. So first I'm going to write about this and then I will explain. It's very easy reaction. We just need to focus on alpha carbon and beta hydrogen. So basically, when a haloalkane, when a haloalkane with beta hydrogen, I will explain what is beta hydrogen here is. Here, beta hydrogen atom is heated with alcoholic potassium hydroxide, alcoholic solution of potassium hydroxide, alcoholic solution of potassium hydroxide. There is elimination, there is elimination of hydrogen from beta carbon and a halogen atom from alpha carbon. This reaction is often called or known as beta elimination. It's called beta elimination. And we can also call dehydrohalogenases. Dehydrohalogenases. You know, whenever there will be a term that is D before any term, that means removal of that term. If there is a term hydrohalogenation, that means addition of hydrogen and halogen. And if there is a term dehydrohalogenation, that means removal of hydrogen and halogen. Are you getting my point? Both of
Yes,
you.
sir.
Please first write it, then I will explain what is alpha carbon, what is beta carbon. It's very easy. Let me know when you are done. Are you done with this?
Yes, sir. Done.
Madhya?
Done, sir.
Okay. Now, first of all, I'm going to again write about location of alpha and beta. Location of alpha and beta, and then I will explain beta carbon in a molecule. In a molecule. So it's very simple. First, I'm going to write it, then I'll explain. Carbon on which halogen atom is attached carbon on which halogen atom is attached directly is called alpha carbon, and carbon atom adjacent to this carbon is called beta carbon. So it's very simple to understand that if this carbon is connected with X, that is halogen, like this, you can see this will be alpha carbon and this will be beta carbon, and adjacent to beta carbon is known as gamma carbon, that you will study in higher classes. So what is alpha carbon? The directly connection of X to the carbon is called alpha carbon, and adjacent to this carbon is called beta carbon. Okay, please write this, then I'll explain alpha beta hydrogen also. Beta hydrogen is like the hydrogen which is connected to beta carbon is called beta hydrogen. Hydrogen connected to beta carbon is called beta hydrogen. Are you done?
Yes, sir. Done.
Nadia, are you done with this?
Yes, sir.
So always remember that whenever there is possibility that there will be more than one beta carbon, so beta hydrogen will also be there like this. You can see this is CH3, this is hydrogen, this is two hydrogen, and this is three hydrogen. So you can see this will be our alpha carbon, this will be our beta hydrogen, this will be our beta hydrogen. And whenever there are more than one beta hydrogen, then there will be possibility of more than one compound. So if I'm going to take an example, a general example for this reaction, and X is here, and like this is hydrogen, and this is like this. So see what happens, there will be alcoholic KOH, and you are going to heat it. X is living group, X is here living group. What will happen here? X will take electron from carbon and it will go. So when carbon will donate electron to X, there will be positive charge on carbon, and this bond will be broken. That means basically the electron of hydrogen will be gained by this carbon. Now this carbon will have two electron, which from which one of the electron will donate here, and it will donate to this carbon, and there will be formation of double bond. And there will be B, that is basically base. B stands for base. That will satisfy this H. So the byproduct will be BH plus X minus. So here how the reaction will go on. Did you get it? What you need to do is just make a double bond between living group X and beta hydrogen. Beta hydrogen. You can see this is our alpha carbon, this is our beta carbon. So this hydrogen is beta hydrogen. So we just need to make double bond between beta hydrogen and beta carbon and alpha carbon, and we have to eliminate X and beta hydrogen. Both of you done with this?
Done. Sir.
Amen. Amen, are you done with this? So please write the product of This is basically OH minus. B here is OH minus. Can you write the name of the product, Madiha and Ayman?
Yes, sir.
Yeah, I'm waiting for your answer.
So the answer is protein.
Very good. So what you need to do is very easy. It's very easy. What you need to do is CH3, CH. I'm going to write it hydrogen, and this is CH2CH. Now you know that this is alpha carbon and this is beta carbon. So this will be beta hydrogen. So just remove this in the presence of this, and you will get propene. Yes or no? I mean, now the next question is CH3, CH2, CH2, CHBr, and then CH3. We are going to react this with alcoholic KOH and heat. Are you done with this, Madhiha? Madhiha and Ayman, are you done with this? Please let me know if you are unable to solve it. Madhiha, am I audible to you?
Yes, sir.
Are you able to solve it,
Yes.
or I should explain it? See, I'm going to explain it. It's very easy. First, you can see this is our CH3, CH2, CH2. I'm going to write it like this, and then CH, then Br, and then CH2 and H. Now see, this is alpha carbon. With respect to this, this is beta carbon, and this is beta carbon. Only beta carbon present is not the condition. With this beta carbon, there must be beta hydrogen. And what is beta hydrogen? The hydrogen connected to beta carbon. So this OH minus, that means basically from KOH. What will happen here is very important. It will be removed or eliminated. So the product will be CH3, CH2, CH2, and then CH, and then double bond. Oh, wait a minute, 4, 5. Okay. And it will be CH. Now the next possibility is basically removing this bromine with this beta hydrogen in the presence of OH minus. So what we will get? CH3, CH2, CH double bond CH, and then CH3. Now, can you tell me what is the name of this product? This is pentene. This is pentene, and this is pent-2-ene. This is pent-2-ene. Can anyone tell me which one is more stable, pent-2-ene or pent-1-ene? Madhiha, pent-1-ene is not more stable. First of all, where there is more symmetry, that will be more stable. So symmetry is more here than here. That's why pen2 is stable. Now the second concept for this, which is very important, we decide this product, which is major and minor, by Sadjeff rule. By Sadjeff rule. Now I'm going to write the Sadjeff rule, and it's very easy. So basically, we can write in dehydrohalogenation, that means in beta elimination, in dehydrohalogenation reactions, the preferred product is that the preferred product is that alkene which has greater number of greater number of alkyl groups attached to the doubly bonded carbon to the doubly bonded carbon atoms. It's very easy. Please write this. Are you done with this? Please let me know.
Done, sir.
Very good. Aman, are you done with this?
Yes, sir.
So you can see along this double bond, it has one alkyl group, and on the right hand side one, and on the left hand side one. Two alkyl groups are here, but here you can see only one alkyl groups are there. So that's why this is major product and this is minor product. So I'm going to give you a question on this. So please write the question. Ready? All the alkene that would be formed by dehydrohalogenation of the following halides with sodium with sodium ethoxide in ethanol, and identify the major alkene alkene. First of all, this should not bother you. Sodium ethoxide in ethanol. It's just the hints for it is elimination reaction. Okay, so the first part I'm going to give you only 1-bromo, 1-methyl cyclohexane. You are going to do the reaction. This is our reactant. Can you do this?
No, sir.
Okay, I'm going to explain it. Please listen to me carefully. First of all, you are going to draw the structure of this. What is the parent chain? Cyclohexane. So I'm going to draw cyclohexane. This is our cyclohexane, and in which 1-bromo and 1-methyl is here. So can I write this like this? Yes or no? Please do this font Iman. So you can see Iman. To this carbon, this Br is attached. This is alpha carbon. This is beta carbon. This is beta carbon, and also this is beta carbon. Yes or no?
Yes, sir.
So we will have 3 products, and after forming the product, producing the product, you need to name the product so that you will able to understand that are you getting 2 same product or not. So first of all, I am going to wait a minute. First of all, red color, this is beta alpha carbon, this is beta carbon, and you know this is also beta carbon, and this is also beta carbon. So I'm going to slide it down slightly, and now I'm going to solve it. So you can see this is our bromine, and this is our CH2H. First, I'm going to solve this. So if this H and this Br will be eliminated, what will be the product
what will be the product? This will be the product, yes or no? I mean,
Yes, sir.
now I'm going to do the next one. You can see this is bromine, and since we just did this, you know that it will have hydrogen since it is also a beta carbon. So I am going to remove this hydrogen and this Br. So I will get a product that will be basically this will be CH3 and like this. Yes or no?
Okay, sir.
Now again the third one you can see this will be Br and this is CH3, and you know that this is also beta, this is also beta. So I'm going to take hydrogen from there and hydrogen bromine eliminating from there. What will be the product? This will be the product. Can you tell me this and this is same, yes or no?
Yes, sir. It's the same.
This is same. That means two products is possible. This and this both. That means two products. This one and this one. So can you tell me which one is the major product?
Sir, the second one.
Second one. Why? Because across this double bond we have only one alkyl group, but across this double bond we have this alkyl group and this two. That's why this is the main product. Either you can take this, either you can take this. Is that clear, Madiha?
Yes.
Please write. Are you done with this?
Sir, can you scroll up so I can copy the question?
Yeah. What you just said?
Sir, can you scroll up because I want to copy the question?
Okay. This was only the first question.